All right, and welcome back. So today we are going to be talking about how we write functions, and there's two ways that we want to talk about. And the first way is going to be identifying our independent and dependent variables. And once we're able to identify those variables, then we're going to be able to write them within an actual equation. So without further ado, let's begin. So when it comes to writing functions, functions have, again, what are called dependent and independent variables. The dependent variable will always depend on the independent variable. And you've probably heard these terms in science. And if so, that's great. If not, you're going to hear them very, very soon. So again, we get the phrase dependent variable because it depends on the independent variable. When it comes to equations, which we're going to talk about in our next slide, your dependent variable is going to be your y, your independent variable is going to be your x. But again, we are going to talk about that in just a few minutes. Let's first talk about how we're going to rewrite each situation with the word depends. We're then going to be able to identify the dependent and the independent variable in sentences and words. If we have a good understanding of it in words, then we can translate that into actual equations that represent the situation. And then we're going to be able to graph it, which is what we talked about in a class before. If we have these graphs, we can change words into pictures. So it's all starting to connect. If we can identify it in words, those dependent and independent variables, we can create an equation, and soon we're going to take that equation and put it to a graph. So it's all interconnected. So let's talk about one example. It says an employee who works longer hours will receive a larger amount in her paycheck. So let's talk about how we're going to rewrite it. What is going to be the dependent variable? What is going to be the independent variable? Well, what depends on the other? Well, the amount of money that they get depends on how many hours they work. So if you work more hours, you get more money. If you work less hours, you get less money, right? So we can rewrite it by saying the amount of money in a paycheck depends on the number of hours worked. And this is just more of a logic-based thinking. We're now taking situations and putting it into what makes sense for us. Another example is a box with several books weighs more than a box with just a few books. So the difference between it is the weight of those boxes. And we ask ourselves, well, okay, what makes the weight of the boxes different? Well, the number of books that are inside of it changes the weight of those boxes. So we can rewrite it by saying the weight of the box depends on the number of books that are in that box. So we can identify the dependent variable, which is the weight of the box, because that depends on the number of books that are inside that box. Again, the dependent variable depends on the independent. The independent can change, the number of books in each box can change, but the weight of the box depends on the number of books, which is where we get our dependent and independent variables from. With this in mind, please work on problems 1 through 4 on the given note sheet and resume when you are ready to move on. All right, if you're listening to my voice, that means you have done the first few problems on the guided note sheet and you are ready to move on. So let's talk about how we're going to be writing functions after we are able to identify the dependent and independent variables. And this is where we're going to be applying to our algebraic thinking the most. So after we're able to identify the independent and the dependent variables, you can write a rule in what's called function notation. Remember that f of x, we also sometimes call that y, is the dependent variable. So the y value depends now on the independent, which is our x. So x will always describe the independent variable because that can change. That can change over time. And when you change that x value, your y value will change with it because the y value is the dependent upon your x. So let's identify the dependent and independent variables, and then we're going to write a function rule for each situation. So it says that a zoo charges $6 for parking and $17.50 for each child. We want to first identify the dependent and the independent variables. So what are we looking at? The zoo is charging some money for parking and for the value of each child, or I should say the price of each child. Children are priceless. You can never put a price on children. So the dependent is going to be the cost of admission. However much money it takes to get into the zoo is going to be dependent on the number of children that you have with you. If you have a smaller amount of children, then your cost is going to go down. The price of admission goes down. If you have a larger amount of children with you, your price is going to go up. So our independent, it's a number of children because that can change on its own, while the cost of admission, the dependent, is going to be dependent on the number of children that arrive. And that $6 happens at one time, regardless of how many children that are with you. Now that we've identified the dependent and the independent, our x is the independent, our f of x, sometimes called the y, is your dependent. So we're going to write that in words. The cost of admission is $17.50 multiplied by the number of children plus $6 for parking. If you bring one child or you bring 10 children and it's in one vehicle, it's $6 to park that vehicle, regardless of the number of children that you have with you. So we're now going to write a function using the cost of admission and the number of children. So the number of children, again, is the independent variable. That's going to be our x, and it's always going to be f of x is equal to something relating to our x value. Well, this equation that we create is 1750x, because it's $17.50 per child. So per gets multiplied with our variable, plus $6 to park. And now we can evaluate that for when x is going to be 4 and x is going to be 10. We want to see, hey, how much is it going to cost if I have 4 children or if I have 10 children? And all we're now going to do is substitute in the value of 4 for x and separately the value of 10 for x. And when we do that, we end up that if you bring 4 children with you, it's going to cost $76. If you bring 10 children with you, it's going to cost $181. And all we did to start out with this was we identified the dependent and the independent variables. The cost of admission, that depends on the number of children that were brought, meaning that the dependent variable is the cost of admission. It's the total cost that is getting paid. The independent is your x, the number of children. And 9 times out of 10, if we are dealing with money or the cost or the price is going to be your independent, your y value, your f of x value. While the number of children, the number of games you buy, whatever you are purchasing for that cost, that is going to be your independent, because that can change. And when that changes, the price changes. Once we found that out, we wrote it out in words, saying the cost of admission is $17.50 multiplied by the number of children plus $6 for parking, because it doesn't matter how many children you have, you're still paying $6 for parking for that one vehicle. And then we write it in a function. We write it as some kind of rule. Sometimes you're going to see y is equal to 17.50x plus 6. It's the same thing as our function notation, f of x, meaning the function evaluated at x is going to equal da-da-da-da-da-da. We sometimes see it as y is equal to da-da-da-da-da-da. It's 6 to 1, half a dozen the other. All right, folks, great job with this. Please now work on problems 5 and 6 on the note sheet, and please jot down any questions that you have as we will go over them together in class. Great job, really, folks. Have a good one.